Okay, everyone, so on this problem here, on a particular piece of road, the probability that a car is speeding is 1/4. The speeds are independent of each other, and the officer sets up a speed trap. Find if the probability officer records 10 cars, he stops 10 cars, find that exactly 3 were speeding. Well, this is a binomial situation, so I'll introduce x belongs to binomial. There's 10 cars, that's the number of trials, and the probability they are speeding is 1/4. And so we want to find the probability that x equals exactly 3. So we write it up as such. We go to our binomial distribution PDF, and we know there's 10 trials. It's 0.25, and it's 3, which gives us 0.250 to 3 significant figures. You have to write the 0 because that means it's included. Going to B part now. If it records the speeds of 100 cars, find the probability that no more than 27 cars are speeding. Well, we have to recognize that this is not the same distribution. It's a new one, so we're going to call it Y. It is still binomial, but our trials is different. There's 100 cars with 25% chance. And so I want the probability that Y, no more than 27 means less than or equal to 27. Now I'm going to do a binomial CDF. I have 100 trials. Still it's 0.25, and I'm going to add up to and including 27, and so that is 0.722. C part now, the hardest one of the lot. If he catches at least 50 cars for speeding, he gets a promotion. Assuming he catches every car that is speeding, find the smallest number of cars he has to check, basically, whose speed he has to record for him to at least be 75% certain of being promoted. Well, we don't know how many cars. We're looking for the cars. We're looking for the n value. As these different values of n, that's what we want. We want to find that value of n. So again, it's a new random variable. We'll call it z. It's binomial, where this is n with my probability is 1/4. And I want to find the probability that z is at least 50 cars, so bigger than or equal to 50. And that probability is at least 0.75. That's what I'm looking to find. Well, my calculator doesn't do this very well, but what my calculator does do well is as 1 minus the probability that z is equal to or less than 49 is also bigger than or equal to 0.75. And if I go over to my calculator, I type it in, and you can see I've already done that here with x, 0.25 and 49. And I have to try and find this value. Because this is discrete, I have to actually look at my table. And if I go to table set, it's starting at 1. Well, I know that more than 50 cars, 75, so I know let's start at 100. And let's go by tens to get a sense of where we're going. Okay, and if I go at my table, it's going to start at 100, it's going to go by tens. And if I take a look what's going on here, I can see between 210 and 220 is where the 75 is. So if I start at 210, let's go back to my table set. Let's go to 210 and then go by ones. If I graph it to the table now, I can see at 215 is 246 or 746. At 216, it's over 75%. I want it to be over 75%. So that means n is equal to 216.